That should make it a little bit easier to see.
They're very interesting
So,
posters.
Tony, you are interested in going backwards in time and debugging and understanding how programs work. Cool.
Well, yeah, I like to enable people to do that. So, are you maybe just like, are you still teaching as a professor? How is your schedule like these days?
So I am now retired,
Mm-hmm.
and I am teaching over Zoom. So I'm actually teaching a high school class in computer science over Zoom right now. So I
Oh,
actually,
that's awesome. Nice. Yeah. So, yeah, I actually think this technology, this time traveling technology, can have a lot of potential in education. In fact, um, I am like I spend some time teaching as an instructor at a coding boot camp a couple of years ago,
mhm.
and basically sort of learning how the students learn, and like learning, like trying a lot of different ways of teaching the students, um, kind of tailored to what they need. And one of the things I found that debugging to be maybe the hardest things to teach a software overall. And since I stopped teaching at a full-time basis, I started mentoring um, at a software startup where I would work with developers that are uh, mostly more junior than I am, and I will pair program with them, or have design discussions with them. Um, and again, I'm in the role of teaching them, and a lot of times I'm trying to teach them debugging, because a lot of times they would have these really tough problems, these bugs they can't track down, and I would work side by side with them, trying to find. And again, I found that, while debugging is maybe the hardest thing to teach of all of software. So yeah, that's something I'm thinking about, and that's sort of largely why I'm going down this path, Chet, like going for this endeavor. Yeah. Um,
Wonderful.
would you mind, like, so like, if there's people watching later, would you mind defining the term omniscient debugging for people? What do you mean by that?
Certainly. So in 2001 or whenever it was, I had free time. So I said, oh, I am going to do this debugger that I've always dreamed about. And now that I have Java, it is really easy to do because of the JVM. And I just whacked out there and did it. Oh my God, I came up with this thing and it worked, not very well, but it worked. And then I started doing research on other people who worked in the area. And I wanted a name. And I said, okay, back in time debugging, okay, it's been used. It doesn't sound very good. And I came up with the concept of, when the debugger knows everything, what do you want it to tell you? So the debugger knows everything. The debugger is omniscient. It knows everything. Your challenge is to ask it the right question. Anyway, so that's where I came up with the term. So that was fun, and makes me feel good.
Nice. Yeah, I think you kind of, I saw the YouTube party, or the Zoom party you did with
Right.
some other folks that are working in this area or are interested in this technology. And
Yep.
you're definitely one of the pioneers in this space, and they all sort of know your paper probably, or have watched your video.
Yeah. Now, what I'm going to claim is my major contribution. It's not just anybody can do bytecode instrumentation, all that stuff. I feel that my contribution was really how to use it. In other words, the idea of, okay, what is it that I want to know? How do I want to see my information displayed? How do I find my bug by going backwards in time? So I feel that that is my real contribution.
Yeah, I agree. Yeah, a lot of I've seen a lot of papers that focus on the recording and replaying and that aspect of it, whereas your focus, well, not the only focus, but a big part of it that's different from theirs is you got this UI developed that allows you to do this. And actually, I did. I'm gonna show this. Let me share my screen. If
Okay.
How do I do this?
A green thing down the bottom, share screen.
Oh yeah.
Do you have a green thing at the bottom?
Yes, I do have the green thing. I found it.
Okay.
Okay. So, oh, there's Adele. Okay.
Hello, Adele.
Yeah, whenever my internet is down, I type hello in my browser, and usually Adele comes up. Before Adele got popular, it was Lionel Richie, I think. But anyway, okay. So can you see my screen? All right.
Yeah.
Okay.
Wow.
Yeah. So I actually got the Omniscient debugger working last night, and I was very excited because I had some trouble getting it set up previously, but I got it working, and I did a code challenge on the LeetCode website, which was this one.
Okay.
I did this one, which was like remove the nth node from the end of a linked list. So
okay, cool.
Yeah, so I did the code and I ran it. I'll show for people watching. I'll show how you run the debugger. So first I would compile my program, like so. Java C remove nth node.java, and then there's a debug script that I adapted from what you gave in your source bundle. So I can say after compiling the program, you say debug the name of the program, and it'll run with the Omniscient debugger. It'll execute the debugger class and passing in my program as the argument of the debugger. Okay, and this is a version of the program that has a bug in it. So there's this stack trace which I really found interesting, because you can look at this stack trace, whereas most of the stack traces that you normally see in programming, it only goes down, it only goes inwards, because right, it's like a coastline that goes, it indents, and that's it, because that's probably the place you threw an error or something. This one, it goes in and then goes back out. And so this is like, you can think of this as like the timeline of your program. Would you say that's right?
So that is the entire call history. So you can just imagine it as printing out a line at the beginning of each function and a line at the end of each function saying I came in and I came out, and it gets deeper and deeper as you go in. So that's the entire program, right?
It's like the outline of the whole program.
Yeah.
Yeah. So here, that's the call history, or the outline, And you can click through here, and then in this code panel, it jumps to the place. I guess it jumps to the beginning of the thing that I selected. And then here you have these step buttons that you can select, and you can see the values of the variables. These locals, the names are like arg0, arg1, var3, var4, var5, but they map back to variables in the current context. So like arg0 is head, and arg1 is n here.
Okay, that is, I have no idea why the names aren't coming in, but normally the names will be there.
Oh, I see. Okay, so there's some weirdness. Okay, about my environment. So yeah. So normally this would just have the names here as for the locals, and then when you click on, when there's an object, you see this notation of the object with these angly brackets, and then you have sort of like an ID, the object ID, and then if you double click on it, you get to see the details of the objects on the right over here. And then this is a linked list, so it's kind of nested. So next is another linked list, and then you drill down is another linked list. So yeah, so this is, I was able to use this debugger to solve all my bugs. One of them was a little tricky, or a couple of them were a little tricky. And in this case, if you drill, I think you can say, click on here or click on here, it goes to the end of the program. I'm already on the last line.
So you're at the end, yeah.
I'm at the end. Okay. Oh, it threw me a little bit here. It says, I got a null pointer exception at the end, and I step backwards, and I don't see the line that was throwing the error. Instead, it was the second to the last line before it's thrown.
So let's see. So I am going to guess, what is the value of place to remove? What is the value of that variable?
Place to remove. Okay, yeah. Place to remove is var3. So it's a linked list. So its next field is null. And
so I assume that is your where you're throwing the exception right there.
Yeah, I think it went I++, and then because current node is probably null.
Well, anyway, why don't I bring up the debugger and give you a little tour as I'm doing it.
Oh yeah, that would be perfect. Okay, I'm gonna stop my share, and then I can let you do it.
Okay. Okay, can you see the full screen real well?
Yeah, I can.
Great. So what we're looking at is we start in main. So there is main. We are at time. Right up here, you can see where you're at event number 2 out of 1,273 events. We are on line 42 of the file demo.java. So that is line 42 of demo.java. As soon as I enter an instrumented method such as main, I immediately record I entered main, and here are the arguments. There is an array of strings. I'll double click on it. It comes over here. It's an array of 0 strings, so it's kind of boring.
Okay.
We can step through the code here. Here is the step into function. And here is the step over function.
Yeah.
And backwards over. So we haven't gone into anything yet. We will in a moment. Let's step forward, forward, forward. And now we will step into the bad method. Let's step backwards out of the bad method. And now we will step over the bad method and we pop down to the catch. So that is what we expected. So we will jump over the bad method again. And up here, we made a vector. V is about to be a vector. Where is V? V is right there. V is what are we? We're in a static method. So V is a static method, a static variable. It happened, we just made a vector there, my vector 0. I'm going to double click on that. And my vector 0 currently is empty. You can see they're all empty.
Oh, okay. Does that mean like it's allocated like space for all those things, but it hasn't filled it up?
So what it means is that I have run the program to completion. So I know the maximum number of things that were ever in the vector.
Oh, I see.
And so I display that way because I don't want the vector jumping around. This way, I can just say right here, I can say, show the first change to the vector, the next value. We added element 0. Show the next change to the vector. We're adding bottles of beer on the wall.
I see. Okay.
And removing bottles of beer from the wall.
Yeah.
But the idea is, and so this is a hack. I hacked this so that it would look good for the human being, so it doesn't jump around.
So you especially for the case of vectors, you handle it this way.
Yes, vectors and hash tables. Let's look at a hash table. Here's a hash table over here. So this is not what a hash table is actually implemented like. But it shows what's going on. And that's what I wanted to do. I, as a human being, can read this a lot better.
And when you click, right. When you click the forward and backward button on the objects panel, does it go to the next update? Okay, so you select some object in this table, and then you can forward and backward to see the next change of this object or the previous change of the object.
So this is go to 0 state. There's the very first element in it.
I see.
This says go to the final state.
I got it. Okay.
Of course, this says previous. The star indicates where you were most recently changed. And you can also just look at individuals. So I can go show me only the changes to 4. And I can also go over here to objects, select instance value variable. Here are all the values of that instance variable. It had 4 beers and it had no more beer. And so I can look at it right there.
That's awesome. Yeah, that's a capability that like we've never had basically, just to see what's the next modification of this object looks like. That's really amazing.
Yeah, so the classic thing is, I divided by 0. I took y over x and x was 0. How did x get to be 0? Let's step backwards in time and see who set x to 0.
Yeah,
so
exactly.
Classic case.
Yeah, and also you jump the execution, so to speak, back to the line of the modification as well. And that's really powerful.
Yep, and let's see. So there we are filling up a hash table. That's kind of boring. And as we move down here, we're just printing things out. There we are. Adding things to a vector. Okay, that's kind of boring. But let's go over here because there are some other threads. We can look at the other threads. So now we are in a different thread. We're in the sorter thread. And the sorter thread is doing a quick sort. So it's anyway, there we go. Sort elements 11 through 9, and we're going to split them off. So there we are, splitting off a new thread to do the quick sort for 11 through 15. And so there we can see the different threads coming up.
Yeah.
And that thread is already dead. He's finished whatever he's doing. I don't know. He sorted 11 through 13. It did not take very much time. And so he exited. So there we see the threads running.
The one, so how does this debugger work with different threads? Like, will there be problems with race conditions and so forth? Will that cause problems for the debugger?
No, as you can see, these threads are all running in parallel. What I actually do is for every time I record information, I take a global lock. So the threads are therefore forced to be in order. So I won't have any multi-threading problems.
Oh, okay.
So it slows it down, and some problems will not occur because of this.
I see. So this would be like whenever you log information, that would be whenever there's a function call, or whenever there's like a modification to a data structure, or whenever you're assigning a variable, assigning a value to a variable somewhere, that happens.
You got it.
Okay, nice. Yeah, this is like incredible. I started working on my Python version of the debugger, but there's a whole bunch of capability that this has that I haven't gotten around to yet.
Yeah. Anyway, let's see what else is really worth looking at. As you can see, I just did TTY output. I instrumented print line. So if you execute print line, I will collect it. If you went in, but only print line. If you do any other way of output, I won't see it.
Yeah. Yeah. So you can click on a out print line, and it jumps to the line that prints the line.
Right. So everything displays according to this event time up here. Whatever event we're at, the entire debugger shows that point in time.
I see. Nice.
Yeah.
Yeah, very cool. Very cool demo. Yeah, this I'm sure. So how did you like you said that like in 2001 you just decided, when you had some time, you finally decided to work on this idea. How did you come up with this idea to start with?
Gee willikers, I don't know. I was working in artificial intelligence when I first graduated from college, and into I went to Stanford Research Institute. And at some point during that time, when I was working with Lisp, and Lisp had a wonderful IDE environment. I mean, that's where all of our environments came from. And I just came up with that thought, like, oh, I could do that. And I sort of played with it and did a little bit of something, but I didn't get anywhere. I had work to do instead. But one of the other guys at SRI, actually, it turns out he had worked on the very first one, EDAMS, I think it is, back in 60 something. It didn't really do anything. It was sort of an idea, and it wasn't practical or anything, but I talked to him years and years later. That's why it was really cool. So Bob Bowles, I want to say.
So I have been working on a similar thing in Python, as I told you. And one problem I ran into in the past is like I'm having to save so much information in the process's memory that at one point I was doing it in the browser. At one point I had this toy programming language that would generate JavaScript to be executed in the browser, and because I had the historical states of all the objects stored away somewhere in an array, that was just too much for the browser. The browser didn't want to give me any more memory, and it just completely hung. Have you ran into like problems like that where you were simply using too much memory?
Well, of course, there is only a finite amount of memory available, and there's only a finite amount of time that I'm willing to wait for it anyway. So yes, total amount of memory used is an issue. If you look at my code, my storage of information is as tight as I can possibly make it. It is, each change consists only of its time and its new value. All of the information is a single word. I do bit packing in words. I've got 32 bits in my array that I bit pack to get as much information as I possibly can. So even there, what did I say? I can only collect a few million events or something.
Mm-hmm. I saw that you had like upper limit with 32-bit computers, but just because of the address space. But then when we had 64-bit computers, that kind of became a non-issue, right?
Yeah, I mean, ostensibly it will grow forever. It's just the question of how long do you want to wait?
Yeah, I see. Um, and let's see, how does your, I kind of want to ask, like, how does your scheme for saving the historical states of all the objects, how does that work?
Okay, so I do not persist anything. It's
Okay.
all in memory only.
Okay.
And so what I do is every time an object, so I come in, I instrument your code as you load your code. Well, you call debug on your program. I have the loader. I wrote a loader.
Mm-hmm.
My loader loads your code, instruments it as it comes in. So I'm instrumenting your bytecode. And then every time I see an object, every time the bytecode registers a new object, then I build a shadow object around it, or parallel to it. It hashes to it. So I have a parallel shadow object. And in the shadow object, I retain the historical information about all of the instance variables.
Okay. So it's sort of like, are those, like, you have a shadow object, and then I think in your paper you wrote for every instant variable you have this history list, which contains all the values of that instance variable. And then I assume, like, for atomic values like numbers and maybe strings, I don't know if you do strings as atomics, then it'll just be the history list is sort of like an array that contains all those numbers or all those arrays. For objects, I imagine it's just like a representation of the object, like a pointer to the object. Is that right? Like, you just have a array of the like, if you assign a different object to that variable, for example, I guess you would just have a, like, at this point in time, this variable was pointing to object A, and then later point in time, the variable was pointing to object B. Is that accurate?
I think so. I think we're saying the right thing here.
Okay.
Just a moment. Let me see if I can pull this off. We have the debugger.
Nice.
Okay, what I wanted to show you was that when you can see Emacs there in the background.
Uh-huh.
And when I go to front of line, oh my good, look at that. There is a exception in the debugger command. Oh, things are going terribly. This is a bad thing. We go back to here to the debugger. We're going to bring up the debugger. We stop recording, and oh, we do not have I was going to show you recorded data. I did not have the debugger working. Why not?
Okay, no worries. That's okay.
Oh, well, anyway, it's not up there. So I was actually going to take you through all of the debugger and show you the pieces of it.
I see.
But
That's all right. That's all right. That would be a really cool trick, though. Um,
I will do that. I will get that working for you later. Well, for
okay.
me too. I wonder what I did wrong.
Okay. Yeah. Maybe we have another meeting later at some point. That would be really cool to see. So one thing you said on your website, I'm gonna. Oh, actually, I want to read you this quote from your paper, and get you to comment on it.
Okay.
So is it notably an informal survey, a show of hands in conferences, classes, etc., of several thousand programmers reveals that roughly 90% of all programmers debug their programs strictly by use of print line. This I take to be a horrendous comment on the state of affairs. Why do you think most programmers use print statements to debug their programs, and what do you think, and could you elaborate on why do you think that's a horrendous comment on the state of affairs?
Give me a heart attack.
Bless you.
I'm presenting, I'm going to different companies, talking to people all the time. And so I asked that question. I was amazed how few people use the debuggers that we have. And even our own Gosling, who wrote, Java.
Yeah.
He uses print line statements extensively. And I was like, you're kidding. And he was amused to see the debugger when I demoed it for him, but he wasn't real interested. He was sort of like, okay, that's cute. Like,
yeah.
Anyway, so no, I am horrified that people are writing in print lines for all the usual reasons, which is there are better ways to do it, like this, and even a regular debugger. I mean, I do print line debugging too. Of course I have. But it's a bitch.
Why do you think that developers do that instead of using a debugger?
Because they've always done it that way, and debuggers are scary.
Debuggers are scary.
They've never had a good introduction, maybe. I'm guessing.
Yeah, I have heard that sort of comment of like, oh yeah, debuggers are something that advanced people use, and I'm not good enough, so I just do print statements, which is an interesting comment, I think, and perhaps debuggers need to be more approachable, or we need to give better training to people about the debugger, or what? Like come to think of it, I haven't seen any classes that would specifically teach you to use the debugger. Like in my college days, I don't remember any professor teaching me how to use the debugger. I don't know. They might have talked about it in passing, but it's certainly not something that was given a lot of thought. And I wonder in the industry, so like nowadays with the way the industry is, a lot of people come into the industry not going through the college education. And like, how do they get their education about how to code? And where does debugging or using a debugger fit in that? Have people been trained to use this?
And I don't know. I started working in writing assembly language programs, and by God, you need a debugger. There's no question about it. And so I didn't even, for me, it was just automatic. And then I went into artificial intelligence working in Lisp, and Lisp has a beautiful system for dealing with exceptions, etc. And it makes debugging super easy. So I personally flowed in that direction, and it was just natural. And I get really pissed off at some of the debuggers that are out there.
Yeah. It is interesting. Like I work most of the time as a web developer, like doing JavaScript on the web page, and we use Chrome as our environment. And I'm actually surprised at how often I find the Chrome debugger to be just a little bit buggy, and I'm like, dude, we have a buggy debugger. How are we supposed to do our work? And I'm kind of guessing some of the time is like, maybe just not enough people are using this thing for them to put in the effort to make this thing really good.
Yeah, it is a mystery to me, but there it is.
Yeah.
Once I got the Omniscient debugger working kind of well, I started writing really sloppy code.
Yeah.
I would not plan out my code. I would just sit there and say, oh, I'm going to type in code. And so that I would have bugs, intentionally I would write too fast so I'd have bugs that I could look for.
Yeah.
And it was great. It was fun. It's like, oh, look at the bug I made. And the great part is when you find the bug, there's no maybes about it. It is right there. You see where it comes from.
Exactly.
And sometimes, other times when you're debugging, you find, oh, X is 0, okay. And you guess the wrong reason why X is 0 going backwards, and you.
Yeah, it's such a great feeling when you know for certain what the problem is rather than guessing, because I see developers guessing before they truly know, and that's such that's such
guilty.
a bad thing. Yeah, that's such, like, I feel like then they're gonna start writing what I call superstitious code, like you don't really need the code, but you're trying to protect yourself against something, and then you're gonna do that all over the place, whether you need it or not. And yeah, a good state of affairs. Yeah.
When we were releasing, I don't know, Sun operating system number, who knows what number it was back in 1990 or so. We were trying to make the operating system, the boot sequence faster, and the boot sequence was weirdly slow. I personally didn't work on it, my friends did. And at one point, they came in screaming, and they're just like, that asshole. Somebody years ago had some timing problems with bringing up the kernels, and you have all the daemons that have to run in the background. And so what he did is he just put a 10-second delay in the kernel. So everything just, they brought up all the daemons and just sat there doing nothing for 10 seconds.
Yeah.
And it's like, well, it worked.
Yeah, I mean, we almost did that last week. I was debugging something with a coworker, and there was this animation that took 250 milliseconds to complete, and if you try to, like, it was like closing a dialogue. Like when you close the dialogue, there's this animation that moves the dialogue away or something, and that animation takes 250 milliseconds. And if you try to close the dialogue and then open the same dialogue immediately before the animation is over, there's a bug. so there's a, well, okay, we can patch over it by just waiting 250 milliseconds. You close it, wait a little bit, and then open another one. That fixes the bug. I'm like, guys, you all know this is a stopgap solution, right? So I didn't let
There are
them
times
stop
when you
there.
have to ship.
Gotta ship,
Yeah.
gotta ship. Yeah.
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 Okay, well, it has been wonderful chatting with you. I looked at your video. I liked it, and the musical interludes and all that. And
Thank you.
you got some. You're thinking this is the most wonderful thing in the world. So
Yeah, thank you so much. I appreciate your time. Would you mind answering just one more question?
not at all.
Yeah. So how have you found, like, how have people received this debugger? You talked about going to conferences and showing it off, and people had really good things to say, right? Can you talk a little bit about the community aspect of this?
I started doing this in 2001, I guess it was, right? And then I started going to conferences through 2002, 3, 4, when I was in Europe, and I was spent a year over there studying in France. I was visiting a professor, etc. So I got to talk to lots of people. I got to show how it worked and talk about it a great deal. And they loved my jokes, of course. I'm clever, I'm funny when I'm talking and all of that. And so everybody was like really enthusiastic and nobody wanted to use it. I could not convince. At one point, at the end of doing this, I would put up $100 bill. And I say, I will give you $100 if you can have a reasonable bug that I cannot find. And I did not get takers. Like that was a mystery to me. So,
that's really interesting. You said like they really like your jokes. Could you share the analogy of the snake versus the lizard?
yes, my favorite.
And perhaps
by the way,
we'll close it. We'll close it with this last one. Thank you so much for your time. I want to be respectful of your time. Thank you.
so we were talking about how the debugger came up and it did not show the correct variable names.
Yeah.
I am suspicious that you have compiled your code with the crush of the, one of the compilers will crush out names and just do minimal naming in it. So it might be a compiler flag that's doing that. I'm trying to remember. There's a reason that I put up those artificial names. I think that was it. There's some way that you don't get the actual names out. Anyway, so you just said
the snake and the lizard analogy.
So yes, if there is a snake in the grass and you find the snake's tail, you can grab the snake by the tail and drag it up. And if you pull long enough, you will get the snake's head. And of course, this is exactly like a bug using the Omniscient debugger. You run the program and it throws an exception, and that's a snake's tail. So you grab onto the snake's tail and you say, why did it throw an exception? Oh, because F was null. Okay, why was F null? And you pull the snake.
Mm-hmm.
Whereas if you have a standard debugger, it is more like a lizard in the grass, because you can see the lizard's tail, but as soon as you grab the lizard by its tail, the lizard drops his tail, the lizard runs away, and you're left with the lizard's tail. And you can't go backwards in time in a standard debugger. So there you are.
Yeah, you have to try to hit it again. I said one time, I said like trying to set a breakpoint is like playing The Price is Right. You have to try to get as close as you can without going over.
Yep. And boy, we all have lots of experience with step, step, step. Oh, shit.
Yeah, yeah, yeah. Yeah, good times, good times. Okay, thank you so much, Bill, for your time. I really appreciate this conversation and you showing the debugger to me. And yeah, I'd love to see if you ever can get the debugger debugging the debugger. I would love to see that. So hit me up if you want to show that to me at any point
It
in
will
time.
happen.
Alrighty. Thank you so much. And I hope you have a wonderful day, rest of your day.
And you have a wonderful rest of your day too. Okay, bye-bye.
Alrighty. Bye-bye.